Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed first 9 questions from exercise 11.2. Hope you have revised well. In today's session, we shall discuss the remaining problems from exercise 11.2. Let's move on to the topic. Before starting the session, let's recall the formulae of lines in a plane. The first one is point parallel form. Vector equation is vector r is equal to vector a plus lambda into vector b, and the Cartesian equation is x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Here a, b, c are the direction ratios. Instead of direction ratios, if direction cosines are given, means a, b, c can be replaced by l, m and n. Next, 2-point form. Line passing through 2 points whose position vectors are a and b. Vector form is vector r is equal to vector a plus lambda into vector b minus vector a. And the Cartesian form, when x1, y1, z1 and x2, y2, z2 are the 2 points coordinates are given to you, means the formula is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Next, condition for two lines to be parallel, that is vector b1 is equal to lambda into vector b2, or a1 by a2 equal to b1 by b2 is equal to c1 by c2. Their direction ratios are proportional, that is in Cartesian equation form. Next, condition for two lines to be perpendicular, that is vector equation are given to you, means vector b1 dot vector b2 must be equal 0. If the equations are in Cartesian form, the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0. a1 a2 b1 b2 c1 c2 are the direction ratios. Instead of direction ratios, if direction cosines are given to you, means l1 l2 plus m1 m2 plus n1 n2 is equal to 0. Next, we learn about skew lines. Skew line means the lines which are neither parallel nor intersecting, and they are lying in different planes, or non-coplanar. Shortest distance between two skew lines we have learned, that is, there we have studied modulus together we have used, but here I'm just keeping separately because it is easy for you to calculate. Then both are same only. Modulus of b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2, and the Cartesian form is determinant x2 minus x1 y2 minus y1 z2 minus z1 a1 b1 c1 a2 b2 c2 divided by root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. Next, we have learned about distance between, or the shortest distance between two parallel lines. There also we use the modulus together while studying, but here using separately, so it's not a problem, both are same. Which one is convenient, you can use it, that one. Here distance is modulus of b cross a2 minus a1 divided by modulus of b. So you have to by heart these formulas, and not only by hearting, you must be able to identify a1 b1 c1 a2 b2 c2. Then when equations are given to you like this form, that is r is equal to a plus lambda b means vector a and vector b, you must be able to identify. Then direction ratios and direction cosines, x1 x y1 z1 x2 y2 z2, all these things you have to just know how to identify from the equations. Move on to question number 12. The question is, find the values of p so that the line 1 minus x by 3 equal to 7y minus 14 by 2p equal to z minus 3 by 2 and 7 minus 7x by 3p equal to y minus 5 by 1 equal to 6 minus z by 5 are at right angles. Here we have to find out the value of p. Two equations are given. The condition is they are at right angles. So when you closely observe the given equation of lines, 1 minus x by 3 equal to 7y minus 14 by 2p equal to z minus 3 by 2. Here 7 minus 7x by 3p equal to y minus 5 by 1 equal to 6 minus z by 5. This is x minus x1 by a, y minus y1 by b, z minus z1 by c, but they are not in standard form. So first of all, we have to bring these two equations in standard form. That means x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Here this is the standard form of the equation of that is one point and parallel, that is point parallel form is this one, x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So the given equations can be written in the standard form as x minus x1, x should be first, so we have to take a minus from here common. So when we take minus common, that minus we have to put it in the denominator. So x minus 1 by minus 3, first part solved. Next, y minus y1, coefficient of y should be 1, but here it is 7. We have to divide through 7. So here, when you are dividing the numerator and denominator with 7, 7y by 7 is y, and 14 by 7 is 2. Here, denominator also we have to divide. Numerator also 7 we have to divide, denominator also we have to divide. That is 2 by 7p or 2p by 7 equal to, this is okay, no problem, z minus 3 by 2. So the first equation is in standard form. Second equation we have to change again, x minus x1, x should be first, coefficient should be 1. So x should be first in the sense we have to take a minus common, that we can keep it in the denominator, that is minus 3p. Then coefficient of x should be 1, means you have to divide with this 7. So when you divide through 7, 7x by 7, that is x. Then minus 1, this should be minus 7. When we take a minus outside, this is minus 7. So minus 7 by 7 is minus 1. Divided by denominator also, if you divide by 7, that is 3p by 7. That minus here is which we have taken from numerator, we are just putting with the denominator because numerator coefficient of x should be 1 equal to, this is okay, y minus 5 by 1. This is similar to y minus y1 by b. This is having some problem, z should be first, means you have to take a minus and put it in the denominator. So z minus 6 by minus 5. Now both the equations are in standard form. So two lines are perpendicular. Two lines are perpendicular in the sense, first of all we have to identify their direction ratios, and the sum of the product of their direction ratios must be equal to 0. So let's identify the direction ratios. A1 is minus 3, B1 is 2p by 7, and C1 is 2. Denominators are the direction ratios. Then A2 is minus 3p by 7, B2 is 1, C2 is minus 5. Since the given lines are perpendicular, as I mentioned before, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. A1, A2, that is minus 3 into minus 3p by 7 plus 2p by 7 into 1 plus 2 into minus 5 equal to 0. That is minus into minus plus 3 into 3, 9 into p is 9p by 7. 2p into 1 is 2p by 7. Here 5 into minus 2, that is minus 10. This minus 10 we are bringing to the right side, that becomes plus 10. 9p by 7 plus 2p by 7 is equal to 10. So when you take 7 as common LCM, and after taking 7 common LCM, cross multiply it, 7 into 10 is 70, 9p plus 2p is 11p. So 11p is equal to 70. Finally we are getting p as 70 by 11. So the value of p is 70 by 11. First of all, here you have to keep it in mind. You have to observe the equation and convert it into the standard form, that is x minus x1 by a, y minus y1 by b, z minus z1 by c format. Then check the denominators a, b and c right, and using the condition find out the value of p. Next we shall discuss question number 13. The question is, show that the lines x minus 5 by 7 equal to y plus 2 by minus 5 equal to z by 1 and x by 1 equal to y by 2 equal to z by 3 are perpendicular to each other. The two lines are given to you. First of all, you have to verify, or we have to check whether these lines are in standard form or not. If not, you have to convert it. Then you have to use the condition a1, a2 plus b1, b2 plus c1, c2 equal to 0. Then you have to prove that the lines are perpendicular. So this question you will try it as homework. Move on to question number 14. The question is, find the shortest distance between the lines r is equal to I cap plus 2 j cap plus k cap plus lambda into I cap minus j cap plus k cap, and vector r is equal to 2 I cap minus j cap minus k cap plus mu into 2 I cap plus j cap plus 2 k cap. We have to find out the shortest distance between the lines. So we have to write the given lines. The first line is written and the second line also we have copied. Then we have to compare it with the vector r is equal to a plus lambda b. It is quite clear from the given equation itself. It is quite clear that it is in the form a plus lambda into b. So we are comparing with the general form, that is point parallel form. Vector r is equal to vector a plus lambda b. We can write, since there are two lines, we can write a1 b1 and a2 b2. Here a1 is I cap plus 2 j cap plus k cap and b1 is I cap minus j cap plus k cap. Then a2 we can write second one 2 I cap minus j cap minus k cap, and b2 is 2 I cap plus j cap plus 2 k cap. The shortest distance between the lines formula, that is d is equal to modulus of b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2. So first of all we have to go for finding the b1 cross b2, that is b1 cross b2 is equal to b1 and b2 are here, this written. Then first row ijk, determinant first row is I, j and k. Then second row we will write as first vector component, that is 1 minus 1 1, it is written here. Next one is third row will come as the second vector's components 2 1 2, it's written. Then we will go for expanding that, there is I cap into that row and column is gone, minus 1 into 2, that is minus 2, again minus 1. So minus 2 minus 1 into I cap. The next symbol is minus j cap into that row and column is gone, 1 into 2, that is 2, minus again 1 into 2 2. So minus 2 into j cap plus, here k cap is the third element, k cap, if you take that row and column is gone, 1 into 1 1, then minus into minus plus, 2 into 1 is 2, so 1 plus 2 into k cap. Then we will go for little bit of calculation. Minus 2 minus 1 into I cap, that is minus 3 I cap. Then this 2 minus 2 becomes 0, that means j cap is gone. 1 plus 2, that is 3 into k cap. So b1 cross b2 we have got. Next we have to go for modulus of b1 cross b2, that is we want it for the denominator. So modulus of b1 cross b2 when you calculate root of x square plus y square plus z square. Here y is not there, so x square and z square we can take minus 3 the whole square plus 3 the whole square, that is equal to minus 3 the whole square is 9 and 3 square is 9. Then that is 9 plus 9, that is equal to 18. So 18 we can split as 9 into 2. When 9 comes out of the square root, it becomes 3. So 3 root 2 is magnitude of b1 cross b2. Then d we can use, d formula directly we can use now because most of the things we have calculated. So d is equal to b1 cross b2 we have calculated here, minus 3 I cap plus 3 k cap. So minus 3 I cap plus 3 k cap dot a2 minus a1. So here it is a2 and a1 we have written. Let's subtract and write, that will be easy and it will be reduced one step. So 2 minus 1 is 1. So 1 into I cap is I cap. Then minus 1 minus 2. Minus 1 minus 2 is minus 3 j cap. Here minus 1, again here minus 1. So minus 1 is minus 2 k cap. Then just to take the dot product, while taking dot product it is quite clear that just multiply the components. So minus 3 into 1 is minus 3 into 1 we can write, later we can go for simplification. Then here j component is not there. In this one j component is not there, but here j component is there, no need to take. Then 3 into k cap and minus 2 into k cap. So when you take, that is 3 into minus 2, it's written here. Then denominator is 3 root 2 as it is. Then minus 3 into 1 is minus 3. Then here 3 into minus 2 is minus 6. So minus 3 minus 6 is minus 9. Minus 9 divided by 3 root 2. Modulus of minus 9 divided by 3 root 2, that is equal to 3 and 9 you can cut 3 times. So 3 divided by root 2, modulus value means without sign will come out, that is 3 divided by root 2. So since the denominator is in irrational number, we have to rationalize. Just to multiply root 2 in the numerator and denominator, that is 3 by root 2 into root 2 by root 2. That is equal to 3 root 2 by root 2 into root 2 is 2. So the shortest distance between the two lines is 3 root 2 divided by 2 units. Next we shall discuss question number 15. Find the shortest distance between the lines x plus 1 by 7 equal to y plus 1 by minus 6 equal to z plus 1 by 1 and x minus 3 by 1 equal to y minus 5 by minus 2 is equal to z minus 7 by 1. Go through the equations. First you have to identify whether the given equations are in Cartesian form or vector form, because there are two formulas we have studied for shortest distance. One is in vector form, another one is in Cartesian form. So here it is quite clear the equations are in Cartesian form because it contains x, y and z terms, just like an algebraic expression or algebraic equation. So the given equations we have written, then compare it with the general form x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Then we have to write x1, y1 and z1. When you compare here, there is a plus sign, but here there is a minus sign. So you have to split it, this one, x minus minus 1. Here also same, here also minus 1. So x1, y1, z1 will be minus 1, minus 1, minus 1. We are splitting z minus minus 1. So that minus 1 we have to take. Denominators a1, b1, c1. That we can take. A1 is 7, B1 is minus 6, C1 is 1. Likewise, the second equation, if you consider here, nothing to change because already in standard form, x minus 3, y minus 5, z minus 7, all minus signs, everything is fine. Just pick and write. x2 is 3, y2 is 5, z2 is 7. Denominators are a2, b2, c2, that is 1, minus 2 and 1. Go for writing the formula. D is equal to determinant x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2 divided by root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. While explaining this formula, I told you that there is a shortcut or a short form. By using that, we can recover the formula if you forget. Better to by heart it, this one. So we can use the alphabets C, A, B, C, A, B, 4 alphabets. If you read in Hindi, it is Bakab. So Bakab is the word, B, C, A, B is the spelling. First of all, denominators, you have to write only the alphabets, the product of the alphabets. No need to write this 1, 2, 2, 1 digits. So first we have to start with BC. I'm not putting any numbers here, only the alphabets. BC I am taking, writing BC minus BC. Next two alphabets, CA. I am writing CA minus CA. Next I am taking the last two, that is AB. So AB minus AB. Once again, first BC I have taken. I wrote here BC minus BC. Next CA I have taken. I have written here CA minus CA. Next AB I have taken. I have written AB minus AB. Then just fill in the numbers 1, 2, 2, 1. Again 1, 2, 2, 1. Again 1, 2, 2, 1. The whole square. So that is the way you have to recall if you or recollect it if you forget the formula while solving the questions. Then just take the distance formula as equation number 1 because we are going to split it this one. Otherwise the calculation will be a little bit lengthier or more space we need to calculate. So just taking numerator and denominator separately. Numerator, if you take x2 minus x1, that is determinant, 3 minus minus 1, that is 4, y2 minus y1, 5 minus minus 1, that is 6, 7 minus minus 1, that is 8. If you write it in proper way, calculation will be very easy to, or else we have to go for searching where is x1, where is y1, like that. So if you write it in proper format, it will be easy for you to calculate. A1, B1, C1 is here, 7 minus 6, 1, A2, B2, C2, 1 minus 2, 1 is calculated. Go for expansion, 4 into row and column is gone, minus 6 plus 2. Then minus 6 into row, column is gone, 7 minus 1 is written, plus 8 into row column is gone, minus 14 plus 6 is written. That is, here minus 4 into 4 is minus 16. Here 6 into 6 is 36. There is a minus sign outside. Here again minus 14 plus 6 is, here minus 14 plus 6, that we will get 8. 8 into 8 minus 8 into 8 is minus 64. So when you add it together, we will get minus 116. That is the numerator value. Then we will go for the denominator calculation. Root of b1 c2 b2 c1 the whole square, c1 a2 minus c2 a1 the whole square, a1 b2 minus a2 b1 the whole square. That also we can do little bit easy way, like a cross multiplication way we can go. b1 c2, b1 and c2 is here, minus 6 into 1, that is minus 6, minus b2 c1, b2 c1 is here, minus into minus plus, so 2 into 1 is 2. c1 a2, c1 is here, a2 is here, 1 into 1 is 1. c2 a1, that is 7 into 1, 7, minus 7 the whole square, plus a1 b2, here a1 is 7, b2 is minus 2, so 7 to minus 2, minus 14. a2 b1, a2 is 1, then here b1 is minus 6, so minus into minus plus, 1 into 6 is 6, minus 14 plus 6. That is equal to calculation, root 16 plus 36 plus 64. That is equal to root of 116 we will get. This root of 116 we can split, factorize, that is root of 2 into 2 into 29. That is, out of these two, 1 2 will come out, 2 root 29 will come. Question number 1, you substitute d is equal to, numerator we calculate as minus 16, denominator we calculate as 2 root 29. Here minus 58 by root 29 we will get, because you are cancelling 2 and 116. Then denominator, if you check, it is in irrational number format, just rationalize it. That is, or else you can just simply do like this. 58 we can split it. 58 when you split, you will get us 2 into root 29. Sorry, 2 into 29. Two way we can do it. First one, either you rationalize the denominator. Here it is a root 29, just multiply 29 numerator and denominator. That is one way. Or else 58 you split it. That is the way we are going to do now. Minus 2 into 29. Then here 29 and root 29 we can cancel it. Root 29 into root 29 is 29. So from there root 29 is cancelled. So numerator is balanced, 1 root 29, here minus 2. So minus 2 root 29. So modulus of d, actually here modulus we didn't write while writing the formula. Finally we are taking the modulus. Modulus of d is equal to 2 root 29. So the distance between the given line is 2 root 29 units. Move on to question number 16. The question is, find the shortest distance between the lines whose vector equations are vector r is equal to I cap plus 2j cap plus 3k cap plus lambda into I cap minus 3j cap plus 2k cap, and vector r is equal to 4 I cap plus 5j cap plus 6k cap plus mu into 2 I cap plus 3j cap plus k cap. So this question you will try it as homework. Move on to question number 17. The question is, find the shortest distance between the lines whose vector equations are vector r is equal to 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap, and vector r is equal to s plus 1 into I cap plus 2s minus 1 into j cap minus 2s plus 1 into k cap. Here when you look at the question, or when you observe the given equations, it is not in the proper format. The proper format should be r is equal to vector a plus lambda into vector b. Means a vector a should be there plus lambda, a constant, into another vector. But here everything is grouped here. I components, j component and k components are grouped and written as a single vector. So let's write the given lines equations and we have to regroup it. Vector r is equal to 1 minus t into I cap plus t minus 2 into j cap plus 3 minus 2t into k cap. Here I components with constants, that we can take as one vector, and t is a constant we can consider, and t we have to take outside like lambda. Then the remaining terms we can form the another vector. Let's group it. That is vector r is equal to constant and the components together. Here I into 1, that is 1i. that means I cap. Here 2 and j, minus 2 and j, that means minus 2j. Then here 3 and k cap, that is plus 3k cap, plus instead of lambda here t is there. That t we can take as common. T if you take outside, here there is minus 1. So minus 1 into I is minus I, plus j. Here it is t is there, and since t is outside there is only 1. 1 into j, that is j. Then here minus 2t is there. T outside going means minus 2 into k cap. So this is in the form a plus lambda into b. Again another equation is given that we have to take vector r is equal to s plus 1 into I cap plus 2s minus 1 into j cap minus 2s plus 1 into k cap. Then here also we have to regroup it like this. First of all, with constants and I cap, j cap, k cap we can take. So here 1 into I, that is I cap, then here minus 1 into j, that is minus j cap, and here there is minus into plus minus 1 into k cap, that is minus k cap, plus instead of mu here s is there. So s we can take s into, here s into I, s is outside, means here there is only 1 into I cap, that is I cap. Here 2s was there, s going out means 2 balance. So 2 into j, that is 2j cap. Here 2s was there, minus 2s. 2s is outside, so minus 2 into k cap. This is also in the form r is equal to a plus mu into b. So both the equations we have changed into the proper format. Now shortest distance formula we know, d is equal to b1 cross b2 dot a2 minus a1 divided by modulus of b1 cross b2. So this formula we have to use and find out the shortest distance. Before that we have to find out this is b1, this is b2, then here this one is a1 and this one is a2. So just find out all these things and substitute it into the formula and find out the shortest distance. So this you will try it as homework. Dear students, today we have completed exercise 11.2, and as I said before, you have to practice the entire exercise and the formulas. You have to recall it, and while practicing and recalling, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.